Hello guys and welcome in this new episode. Today is a very good day for me because as we can see here, I finally have something interesting to display. I have been working like crazy on the ProLand integration in my engine, and that was absolutely tricky. But yeah, this is the first kind of interesting result, I would say, that I can produce with yeah, this the result of this integration process. So what you have here is actually a single proton terrain. I guess I can show you that in yeah, we'll get back to this display here. I had just prepared this page, but maybe I can just duplicate that and navigate to where is it? Where is it? Let me think about it. One second. Okay, so what I had in mind is this page. What I've been working on mostly currently is are the examples for the terrain plugin. So if we go there, we have this terrain one example, and so this is a terrain that I'm trying to construct here. Obviously, it's not displaying exactly the same way because well, the implementation is still incomplete. In fact, what I have available here is only the computations of the elevation values for every well, every pixels, every location on different quads, if you want. So in fact, if we can just zoom out a lot, I guess it's a bit slow because I have also reduced a bit the speed of the camera on the terrain. So give me a sec. Alright, so what we see here is a complete terrain, which is going to be subdivided progressively in different layers, and for each layer you will get a different number of quads because you will divide each quad from the parent layer into 4 quads. And the problem I could say here is I'm not displaying those quads anymore. I've been working on a lot of other recording for that, so maybe I can just show you that too. Alright, so I've been posting a few of those implementation steps, if you want, on Twitter. So this is the display that you would get if I were to activate a kind of different coloring process for each quad. And so you see that even if you don't notice that on the image itself when you're moving, there is a subdivision process occurring when you need to increase the resolution of your quads. So that's the whole idea with this ProLand mechanism. If you look a bit far away, you can see some kind of mountains, but they are not very well defined initially. But the closer you will get to those mountains, the higher the resolution you will get for them. So, well, we could go even much higher than that, but I am currently only displaying 7 layers, and this is defined in the very minimal example that I'm producing here. And this is implemented similarly to all the other examples that I've been constructing for WebGPU so far. So you, oh wait a second, why do I see, no, there is no, oh yeah, that's another thing also. There are still a few crashes from time to time, but not that many actually. But of course, now that I'm recording, you will get this crash. This is one of the two, I mean, I guess it's the same issue, but I still have an issue occurring in the process where, you know, I am using this, this is also coming from ProLand actually, this task graph system, which is used to build task graphs and then to control the execution of those tasks depending on dependencies that you have between different tasks. So what I have here is I have first task that I would expect to execute, and then a second task that should be executed once the first task is completed. And what I've noticed is that in some cases it could happen that I am starting to execute the second task even when the first task is not marked as completed yet. So yeah, pretty nasty, but so far I could not really figure out why. What we're talking about very tricky and complex multiprocessing setup here, so I need to take some more time to think carefully about it. Usually you can, if you take your time, you can figure out what's going on here in those cases, but yeah, still to be investigated. Anyway, what was I saying before that? Yeah, this is the whole setup of the application, and something I'm noticing here is I would expect to see an environment map, this bridge 2 map. Why am I not seeing that? So where did I create a scene? Get or create scene. Add render pass. Oh, no, actually no, I'm just not adding the environment map, right? And then you have the add terrain here. So scene point, what do we do with that? Add render pass and that's it. Okay. I guess I could add an environment map, but it's not really important here. Well, so what should I describe or mention about this? Not quite sure. There are far too many details to cover anyway, so I can just kind of provide an overview of some interesting points, but we're probably not going to go very deep because that would take way too long. Except if someone is interested in getting more details. In that case, let me know in the comments, of course, and I can maybe make another recording for that. So let me see. Okay, so one of the first important element, I would say, with this introduction of the task graph system to control the rendering of the complete scene, in fact. So if we go into my engine class, web GPU engine, now we have, for instance, this main function, which is render frame. This one is going to be called in the I think we have the ProLand SDL. Yes, land SDL actually. And in this one, when we do the full application loop, if you want, so you have this one, and now we're doing this part. We're using the scheduler to execute the render task, and the render task itself is just going to call render task, render frame here, and this one basically just called the engine render frame function. So we are just ending up here, and starting from here we have those tasks everywhere, in fact, and you have mostly task into task graphs, and you can have task graphs into task graph also. So you build your kind of task hierarchy like that. So for instance, what we have here, we have this render task, which is going to be a task graph, and you're just constructing that once. And in there, I'm going to add one task, a first task, and another task here, task 2, and another one, which is task 3. And well, that's where I also started to drift a bit further away from the initial implementation that we have in ProLand, because I am adding, for instance, this concept here of a perpetual task, which means that this is a task that is never really going to be completed. I mean, it's going to be completed when you execute it once, but the next time you want to trigger the full task graph again, during the initialization phase of the task graph, you will reset the state of that task to not done, and so you will have to execute that task again. And if you execute a task again and you have dependencies from this task, so for instance, here what we have is task 2 depend on the task 1 and task 3 depend on the task 2. So we are building those dependencies just after here. And so if we have to re-execute this one, you're going to trigger cascading cascading changes for all those tasks, so you would have to re-execute all of them, which means that for every frame I'm basically oops, don't try to move that manual please. I'm basically re-executing all those 3 tasks one after another, which is working fine most of the time, but typically this is also the location where I have this strange issue occurring when I've been rendering millions of frames usually, but sometimes a bit sooner like we've seen here, because we were not executing that since very long at that time. And yeah, I can't really explain that, but I get back to that. Okay, so then we have, for instance, the scene manager here, which is going to be responsible for all the scenes. And then in the scene themselves, we have another example of those tasks where you cut the rendering process into multiple subtasks if you want. So that's it, it's a process task. You again have a first part here where you update the camera buffer and so on, and then the second part where you're going basically to start rendering everything with web GPU for this specific scene. Another quite important thing that I added, which is drifting away from the original ProLand implementation, is the concept of subtask that we can add in a given task dynamically. Because one of the limitations I found with the task graph system was that basically you have to construct the task graph once, and after that it's very tricky to update the task graph while it's being executed. You have this initialization process when you request the execution of the task graph itself, but I found that it was not really enough, because when you want to, render your terrain, for instance, what's happening is actually you're going to traverse a complete hierarchy of quads, parents and children quads, and then so on, as long as you need to subdivide the quads. And it's only at that point that you will decide that okay, this quad is going to be visible and rendered, or it's still too big and you need to cut that into 4 sub quads, and you need to keep going down in the hierarchy. And that's where you decide, okay, this part needs to be rendered, this part needs to be rendered, and so on. And in the initial implementation of ProLand, this whole quad traversal process was done in the main thread before producing a task graph, and the task graph itself was only collecting the task needed to generate the tiles that you want to use for the display of the quads. A bit of a tricky sentence, sorry about that, but I hope you understood what I mean. Anyway, what I have decided to do myself is to consider the traversal process of this quad hierarchy as a task also. So basically I have a task, and during that task I'm going to build a task graph. And the point is, I need this task graph that I'm constructing dynamically to be executed before I try to render anything for the current frame, because otherwise we won't be ready. There would be some tiles that you need to generate first that could be missing. So yeah, at that point I really needed a mechanism to say, okay, I am currently executing this task, which is my parent task, but I really want to add some subtask that I really want also to execute before I can consider that this parent task is completed. And it's only when the parent task is considered completed that you can move to dependencies for this parent task, if any. So yeah, and this was also pretty tricky to set up, because this led me to countless issues, synchronization problems on multiple threads at the same time. Pretty tricky to set up and to get done correctly. And actually, could also be that this is the reason why I still have this issue. Well, to be investigated, as I said. So yeah, but definitely very useful system. Okay, let's see what's next. Okay, so next major stop is the introduction of the tile simpler class. This one is also coming directly from ProLand. And the tile simpler basically is going to be used to bridge the link between a terrain node. So we have this main terrain node and one or more tile producers that you want to display on this terrain. With this mechanism, in fact, things are getting a bit dynamic, if you want, when it comes to the setup of the shaders and the rendering process. Again, pretty tricky stuff in the end. But let's try to give you an overview of that. So the idea, for instance, here is when you're constructing a terrain node, you're going to provide some details for the construction, and part of this of those details would be the list of samplers that you want to use during the rendering of this terrain node. So what I have, for instance, let's get back to the example here. When I'm creating my terrain, terrain here, I'm going to provide one sampler only, which is a tile sampler, and this is going to be linked to a producer, an elevation producer specifically. So then when you have those quads rendered as part of the terrain node, you will be able, using the tile sampler, to figure out, okay, if I'm displaying this quad at level 2 with coordinates 1 1, for instance, I know that when it's time to render this part, I need to access the elevation tile, which is using those same level and location coordinates, and this is located in the texture number 3 at layer 4, something like that. So you can then link this information into the rendering process to figure out how you're going to access your elevation tile during the rendering. So yeah, that's it. What is a bit tricky, I would say, in the end with that is you could decide to do it differently, but for my part, I wanted to push it pretty far and to be able to have a flexible shader that would accept different number of tile samplers, which is making things pretty tricky, because for each sampler, for instance, if we just consider the elevation sampler, the only one we have here, this sampler is going to use a tile cache, which is a GPU tile cache, so it's using a texture 2D array to store all the tiles, the elevation tiles that you want. And the 2D array, with the 2D array, you can only have 256 layers on a single texture. So if you want to have more than 256 tiles, you, for instance, could need 2 textures, so maybe even 3 or 4. So, and when it's time to render your terrain, the other thing is, we're not going to render all the tiles one by one. We are actually rendering them all together, which is another very cool thing, and I want to get back to this in a moment. But anyway, so if you want to render all of them together, it means that your shader needs to have access to all the textures at the same time. So you could have maybe 4 textures just for the elevation, and then you need to figure out which one you want to sample for a specific location on a given tile, on a given quad. And yeah, this part is tricky because I've been searching for that, but I don't think that in WebGPU currently you have support for something like a a texture array of texture array. Yeah. I don't think this is possible. I'm not even sure you could do something like that with GLSL or another language. I mean that, yeah, that's a bit too much, I think. So what I'm doing is I am actually injecting some code here, which is generated procedurally depending on the number of samplers that I have. So you see that I'm preparing the definition of a preprocessor variable, and after that I'm going to iterate on all the textures, define also dynamically the binding for that texture, and provide this part of code, for instance, which is going to be in a function then which I use to sample from a given texture, which means that in the end, in the shader itself, things look pretty simple and nice. You have this part here where you have the definition. Oh, noisy, sorry. Where you have the definition of all the bindings, all the textures that you might use. And then you have this helper function, sample tile, which is going to sample any kind of tile storage as long as you provide it the appropriate coordinates and so on. So in there, you get the texture coordinates from where you want to do the sampling, and the layer, because all the texture are going to be textured to the arrays. But you can have many of them, in fact. And the magic part is occurring here, but this code is not even written here. It could depend on the number of tile samplers that you're using for your current terrain node. So pretty nice, but also making things a bit more complex, that or a bit more confusing, I guess, if nobody knows about this. But anyway, it turned out to be working fine so far, so I'm going to keep it this way for the moment. So is there anything else to mention concerning those tile samplers? Let me see. Okay, let's try to keep things short. Short is a big word, I guess. Not too long, let's say. Next thing maybe I could mention very quickly is I have also added support for using a debugger in Visual Studio. So if I just press F5 here, you will see that I'm actually starting a debugging process, because without that it was just impossible to, well, resolve all those issues with the task graph. And now I'm going to use that more often, I think, because it's pretty handy when you need to do some debugging investigation and avoid typing too much of those debug output messages which have been used to do so far. Okay, yeah, but I've actually made another recording for that, so if you want some more details on the debugger usage itself, you can just check one of those previous recording. But I'm not going to get back to this here. What else do we need to cover? Okay, so let's talk maybe a little bit about the actual shader processing itself. What I'm doing now is I'm using this one, this displace elevation. Yeah, very nice name, man. Very good. Before that, I was using just this one, the display elevation value, and I think I have also another. That's it actually. That's elevation just displayed when they were displaying fine. But of course, things were significantly more tricky at first. So that's actually the first display that I got. When you try to display some noisy elevation value, but you still expect some kind of consistency between the different layers, because that was what it was supposed to do. But no, not at all. One of the major thing I think I should report here is when you're working with web GPU. Let me see, where do we have that? it was in the display elevation shader itself. So I have that somewhere, I'm sure. Yeah, it's in the sample function. When I was to display a given layer from one of those texture to the array, I was providing, you know, in those coordinates, the layer that I wanted to display. But when you are in the C++ side, where do I write that? Never mind. So you can understand that when you write the data for your uniform buffer, you are going to write that. Well, you could maybe write that as an integer separated, but I'm writing everything as a vec for f for the chords, and then I'm doing the conversion back here. So the value I'm reading for z is really an integer value that was converted to float value. But if you just do this, oops, sorry, you don't have the plus 0.5, then you just try to convert that to an integer dynamically, you will get so much garbage. It's unbelievable. So I don't know, the rounding process doesn't seem to be that precise. I would have expected this to still kind of work. I mean, even if there's no absolutely guarantee, of course. But no, definitely no. So you must be very careful when you try to convert your float value back into integer values. So you just need to add those plus 0.5. And yeah, this was basically the difference between the complete mess that I was getting initially and something a bit more usable than, which was still pretty far from okay, actually, but never mind. So keep that in mind. And then what else should we mention about that? As I said, also, a very cool thing that I'm pretty happy with is when you're doing the rendering, I mean, okay, let's just start another debug session. When you're doing the rendering here, you see, for instance, I'm reporting that I'm currently rendering 140 quads. And in fact, for each of those quads, well, can I enable that? Let's maybe try to enable that. If I go into the displays, I think it's this one. If I enable that, it's going to tweak a little bit the color that is displayed. So instead of reporting all the field, all the RGB fields with the value of the elevation, you set the green field to 0, green channel, sorry. But not all the time. Only when this value gives you 0 when you take the modulus 2. And this offset, input offset, is something that you're receiving from the vertex shader as part of the vertex output. And it's the value that we have here. And what we're computing here is we're taking, well, I'm using the z part of it. So this is a vec2. This is a single value. I mean, not the z part, the w part, right? Yeah, w. And for w, I'm taking this dot of the coordinate, q coordinate with 1, which is just giving me the summation of the coordinates. And those coordinates are in fact per geometrical quad in the full quad that I'm going to render. Because every quad that I'm rendering, I'm actually using a grid mesh to render this quad. And so we have a count of number of geometrical quads, if you want, in every quads that you want to display. And currently, I think I've set value to 12. So it's going to render 12 by 12 quads for every quad. I should find another name for those quads. Anyway, if I enable the display here, this is what I'm going to see, those geometrical quads. So let's save this and try to execute it. Oh, okay, I mean, move here. And so here you have it. You have all those, well, geometrical quads. And if you move away, you can see that the resolution of those quads is changing. But this is, of course, not the actual terrain quads themselves, because you have 12 by 12 of those geometrical quads per terrain quad. And why was I saying this? I don't remember. Let me think. Okay, now I remember. I was talking about the fact that we use a very big buffer. I mean, it's not so big in the end, but we use a single buffer to store all the information we need for the rendering. And then when it comes to render the quads, terrain quads, there is a single draw call. So all the full terrain here is rendered with a single draw call. It's an indirect draw call through. And what you're going to provide here is basically just a number of vertices that you want to display. And to compute the number of vertices, this is what we have, for instance, the terrain node here. Where do I have that? Num drawn quad, for instance. Okay, so this is the number of terrain quad that I want to display, and that's it. So for each terrain quad, I'm using this grid size. For instance, if I know that I have 12 by 12 geometrical quads to draw, for each of them I'm going to use 6 vertices. So I use 12 by 12 times 6 to figure out how many vertices I want to display. And this is what I'm going to provide for the rendering information for the indirect draw call. And then when it comes to do the rendering, in the displace elevation here, we use a vertex pooling mechanism. And so you use simply the vertex ID, and from that you can figure out actually what terrain quad you're currently rendering, and then in this terrain quad which geometrical quad you're currently rendering, and then inside this geometrical quad what triangle you're currently rendering. So you go through this with this process here, and also once you know which terrain quad you're rendering, you can then use this index to access the information that you are provided to display the specific terrain quad. And this is provided from another storage buffer, right? Yeah, the storage buffer here, which is providing all the information that you need for the rendering of a specific terrain quad. Currently, we only have this offset value plus, as it is the case here, since we have the elevation tile available for all the terrain quads, we have also additional information provided in the buffer to figure out how to access the appropriate tile, the appropriate elevation tile. And again, this information is going to be set up by the elevation terrain simpler object that we are associating to the terrain node. Okay, so pretty tricky, right? But yeah, in the end, it's when it comes to the performances, I guess we could hardly go any further than that, because yeah, you're rendering only what I feel might be maybe not the most optimal option. well, not option, but if you think about it, not quite. The thing is, when you use vertex pooling, you have this indirect access to the vertex information. So whenever you are in your shader here, you need to get the quad index, then you have a big buffer here and you need to retrieve some data from this buffer, which is giving you a lot of flexibility. You can access actually the data for the current quad, but also the data for the next quad or the previous quad or things like that. You could even, in a specific quad structure, store the information giving you the index of the quad, which is, well, of the neighbor quads that are going to be rendered. Might be interesting or useful in some cases. But anyway, this is very flexible, but it also means that there is an additional cost compared to providing all the information directly into a vertex attribute, because with a vertex attribute, you have those big vertex attribute, and for each vertex, you're providing all the data as input to your shader, and there is no access outside of this, well, in the outside buffer. But if you think about it also, now, for instance, since we're rendering 12 by 12 sub-quads, and for each of those 12 by 12 sub-quads, we will have 6 vertices. If we were to provide a vertex attribute, it means that we would need to duplicate the information that we have here for the quads for every single vertex, which I also think is maybe not that optimal. So maybe vertex pooling here is not so bad if you think about it. I have not really done any kind of investigation on the well, kind of performance differences you would get on this, because I didn't want to even try providing that as a vertex attribute. But yeah, maybe one day if I already have a lot of time. Anyway, oh my, so long already. Sorry. I don't know. I mean, I could provide more detail on that, but I'm not sure it's really relevant at this level. So probably, yeah, we should stop here. What I should mention to conclude is the next step maybe, which is going to be to add support for the normal producer. In fact, this is still part of oh, I didn't even mention the the blending part. Okay, I need to mention the blending part because it's also pretty cool. So let's try to do that. Stopping this, I am going to disable the coloring here because it's kind of preventing you from really seeing what's happening. And next, let's try to do things without the blending part. So let's say H would be just the final value that we have computed in the current layer, current level of details, maximum level of details for the current location, and not blending that with the parent version of it. So if you do that, what you get, in fact, for the display result is this. So you get this, the popping, if you want, between the different level of details, and you can clearly see if you look at the junctions between the different tiles that when you switch between one version and a parent version of the tile, obviously in the parent version you get twice less vertices, so twice less details, and at the border, if you have a highly detailed tile next to less highly detailed tile, you get those kind of issues, which is pretty standard in terrain display, where you have gaps between the tiles. So this is well, not very good. And next for that we have, it's part of the ProLand engine, so they have introduced support for a blending effect, which is very interesting if you think about it, because the idea is basically when you're rendering the elevation tiles, you're going to render the information for your current level of details, but you're also storing in the same tile the corresponding value for the parent level. So it's less precise, it's a coarse value. But then what you can do, in fact, is when you use this blending effect, you're going to blend between the parent value at the current pixel location and the highest resolution value that you have, depending on the blend factor here, which is centered on the camera. And so it's allowing you to smoothly transition between a high resolution version of the tile and a low resolution version of the tile, so you actually hide those transition that you can see, that we could see just before. And actually I have implemented support for displaying this blending factor at some point, because obviously I got it wrong the first time I tried to do it. So if we display that, it's not going to show exactly the same thing as what we have here, but still, we get the idea. So this is the blending in action, moving between green and red. So pretty fun if you think about it. And if you activate that, as we've seen, we don't have this popping effect between the different tiles. And so that part is just above here with H, where you do the blending between Z value, which is the highest resolution version, but clamped to 0 actually, and what you have in channel Y, which is the coarse elevation at the same location. Okay, I think with this I have covered all the important point, I would say, and this recording is already way too long anyway. So yeah, if you have any question and you think I should provide more information on anything, just let me know in the comment, as I said, and otherwise I will continue on my side and introduce support for those normal tiles, and that should improve the quality of the display further. So that would be cool actually. So thanks for watching and see you another time. Bye bye.